Good morning and welcome to Creative Math Materials. I'm Lorinda Wagner. I am the lead teacher and assistant supervisor for the Cuesta College Children's Center located in Paso Robles.
And I'm Maddie Chevalier. I am a coach and trainer for Quality Counts in San Luis Obispo County. And with us today in the moderator role is Bobby Cesania. She is a coach with Early Head Start, and she is the invaluable third member of our team.
So today's workshop goals include an overview of early math development, our roles as educators, and exploring math materials that you can create. Now, originally, when I've presented this workshop, we've been able to be in person, and you would hopefully be able to explore these materials that we've created. But we have taken some pictures, so we will be available to answer any questions after this workshop. So thinking about mathematical development, educators are there to support and facilitate children's development. We can guide and support and challenge children in their journey of exploring and constructing their knowledge, supporting their knowledge and skills over time, right? Mathematical development is a continuum. We can provide a mathematically vibrant environment. We can model mathematical thinking and reasoning. And we can also introduce math language. The information that we're sharing with you today comes from the California Preschool Learning Foundations and is supported. You can find this resource online. So in the Preschool Learning Foundations, there's 5 strands of mathematics. They include number sense, algebra and functions, which includes classification and patterning, measurement, geometry, and mathematical reasoning. We'll be exploring these a little bit more in depth.
And of course, if we've talked about the preschool learning foundations, we also have to talk about the DRDP. And hopefully many of you are familiar with the DRDP and its use as an assessment tool for young children. Now, the DRDP has a few different measures that relate to math learning. First of all, we're talking about COG 1, which is spatial relationships, where the child increasingly shows understanding of how objects move in space or fit in different spaces. Then we've got classification, where the child shows an increasing ability to compare, match, and sort objects into groups according to their attributes. COG 3, number sense of quantity, where the child shows developing understanding of number and quantity. COG 4, number sense of math operations, where the child shows increasing ability to add and subtract small quantities of objects. COG 5, measurement, where the child shows increasing understanding of measurable properties such as size, length, weight, and capacity, and how to quantify those properties. COG 6, patterning, child shows an increasing ability to recognize, reproduce, and create patterns of varying complexity. And finally, COG 7, shapes, where the child shows an increasing knowledge of shapes and their characteristics. And of course, you can see how these are related to the strands and substrands of the preschool learning foundations and how these all work together to create a cohesive understanding of children's development and learning, and specifically in the area of mathematics.
So under number sense, California Learning Foundations also has an infant toddler version. So as infants and toddlers, they're developing an understanding of numbers and quantity. There's one person that walks into the room. As children grow and become preschoolers, children 36 months through 60 months, they start to understand the important aspects of counting, number relationships, and operations. Number sense is divided into several substrands, so including counting, number relationships, and operations. Under the area of counting, you have rote counting, which is just that memorization of what number comes next. 1, 2, 3, 4. Young children might be able to rote count without that understanding of what those words that they're saying actually means. Recognizing numerals so that a written number represents that word. A 3 is a 3, a 4 is a 4. And then true counting, where children understand that numbers represent an amount of something. Then you have subitizing, and this is when children are able to look at a small amount of something and know that it is a number. So the pips on a dice is a great way for children to start to learn and subitize that, oh, when I see 3 dots, that means 3. Children also develop one-to-one correspondence, meaning that each thing is equally represented. Arithmetic, that's problem solving of adding and subtracting in small quantities, usually for young children. Cardinality is when children understand that the last number counted represents the quantity as a whole. And then also quantity, that numbers represent quantity. So next we'll be sharing some photos of examples of this throughout our classroom. So this is a game that we've created using a die, and we have these gems and each child has a box. So playing games are rich in mathematical development. So this child has rolled the dice for the game and picked out that number of joules. So that quantity of objects. Stacking blocks, they're seriated, but they also have numbers. This little boy is pointing to the written numerals and was able to represent those, saying, oh, the zebra is a 5. Oh, the snake is the shape of a 6. This is bubbles. And this little girl had created this bubble chain and as she added each bubble, she counted along with them. So as you can see, it's very symmetrical until the very end of it. The next one, so this is a young 3-year-old. Actually, when she was in my class, she was still 2. And we were doing a special project and I wanted them to understand that they were able to pick 5 beads, but knowing that some of the children in my class might not have an understanding of what 5 was, I drew 5 circles. And as they picked out the beads that they wanted to use, they placed 1 in each circle to help them understand that 5 was a quantity of beads. Books also support number sense. I'm sure that you are probably all very familiar with Cat. This is a tray that I created using just some cardboard and magnetic letters, and then I created some little buttons. And the children were able to retell the story. But this also is supporting mathematical operations and and subtracting a button, right, as each one pops off and rolls away. Here's another dice game that we have. So we have little carrot erasers. I am very conscious of how much money I'm putting into my classroom. As many educators, I think a lot of our own paycheck goes back into our classrooms, and the dollar store, thrift stores, and the dollar bins at Target are a great resource to find things. So I use those little erasers a lot. They have them quite often. Be aware of the children that you're working with and any possible choking hazards. And then these little baskets that I found that look like rabbits. So in this game or tray, they're feeding the rabbits carrots that match the representation on the die. And she's actually using some tongs for additional fine motor development. This little girl providing a whiteboard where the child's like, I really want to write my number. So she understood that her number, her age, could be represented in written numbers. So she's making the number 4. And also it comes up in number sense, comes up in other ways of building. So this little one was using some builders that we had, and he goes, oh, look, I made a 2. And he's like, can you take a picture to show my mom? At snack time, numbers and math talk are usually pretty prevalent in my classroom. So this little boy created the number 9. We then continued our conversation about, well, can you show me 9 sticks with your pretzels? And then the numbers continued around the table. So we had a little one, and they discovered that 8 is a very tricky number to make using straight pieces. But they did end up doing it. They just broke their pretzels into very small pieces to create the number. And then also here's another example of written numerals. Mo Willems is probably one of my favorite authors and comes up very much in our conversation. And for those that don't know, this is Sneaky Pigeon. His birthday happens to be April 1st, and our class wanted to know how old we thought Pigeon was. So you can see their representation of numbers. This little one over here on the side, 25 is what she thought it was, and she needed help. So we added some dots to show her that this is how you would make a representation of 25. So here are some activities that we've created to help support children's number sense development. So this one, you could use children's phone numbers, ask parents for permission. Most of them don't have phones like this, but representing those numbers and then a button that you can push is something that they do enjoy doing. So here again, we have one of Mo Willems' characters. This is Gerald, and this is his imaginary phone number. So children can recognize the numbers that are written on the piece of paper, and then they can continue to push them in on the phone. We sing a song of 10 in the bed, and so I've created a literacy tray that goes along with that. So I've used just some old-fashioned clothespins and painted them, and then the bed I created using a tin and covering it with some fabric. And so the children sing along with this song once they're familiar with it. And it's 10 in the bed, and the little one said roll over. And so they're all able to roll over, and then the one on the end falls out. But I also provide the written words for any of our adults that might not be as familiar in our classroom. This is a simple shell game, just some shells that I found at the dollar store, and we've painted some numbers and dots to represent those numbers, so the quantity, and we play a matching game, kind of like a memory game of where they are. And this was another one. It can be used in a variety of ways, depending on how you place the rocks on the paper. So in this example, this one's showing the numbers match the dots in the way that they fit, as also with spatial relationships on the way that they fit on the piece of paper. But on the reverse side of the rock also has the written numeral as well as the word 9 or 1. But they fit depending on which way you have it. And then we also have another one where there are just the numbers written, and you would place the rock with the dots that match. 5 green and speckled frogs. This is a cookie sheet, a piece of fun foam that we've created, like a crafting foam that we created a little log. And then these are just bath toys that we've gotten at the dollar store. I've also done this in a basket where I use a scarf, an actual log, and these same frogs. So providing opportunities for children to explore familiar songs that are rich in mathematics in a variety of ways. Here's another one. These are little ducks. I'm thinking that they were maybe egg holders. I'm not really sure what they were, but we created them into these little puppets that sit on these little sticks. This is a pool noodle that we've just put little holes in the top that fit the tongue depressor size sticks, and they can sing One Little Duck Went Out to Play. And those ducks are then represented with these little sticks. Children can act this out in a variety of ways. This is a card game that we created. So this is another one good for subitizing because you can represent those shapes, matching number sense. So these cards, I believe, were from the dollar store, and they had pre-cut rectangles that sit inside. So that's what we cut along in order to create this kind of frame and insert of a match. This is another simple game, one-to-one correspondence. So we have stickers of puppy dogs and kitty cats, and we have little bones that I found maybe at the craft store around Halloween, and I thought, I wonder what I can use these for. And then little wolf balls, or you could use pom-poms. And so I might add a pair of tweezers or a little spoon, where the children are to give each animal a bone or a ball, depending on what kind of animal it is, one-to-one correspondence. I always keep my eyes open for little boxes or trays like this. And this is another activity that would be out on a shelf of numbers representing quantity and placing the corresponding amount of shells in each box or space. And you can see that I've included 0. Oftentimes when we're talking about numbers, we don't include 0, but it is an important part of our mathematical system. And then also, I've also put in the dots underneath the written numeral. So the next strand of mathematics is classification and patterning. For infants and toddlers, it's considered classification. And as children are developing, they are developing the ability to group, sort, categorize, connect, and have expectations of objects and people according to their attributes. So if an infant or a toddler sees something that, say there's a basket of balls, and if they see that there is a block in that ball basket, they might remove it. That is classification for young children. As we move into the preschool years, it becomes algebra and functions. which also is sorting and classifying objects, recognizing, extending, and creating patterns. So the substrands and foundations for classification and patterning include children's understanding of sorting, classifying objects, sorting and classifying objects by one or more attributes, expanding their understanding of simple repeating patterns, as well as recognizing and duplicating simple repeating patterns. And then they continue to extend and create simple repeating patterns. We see this in children's play quite often as they sort objects or put things back in different ways, or also creating patterns. Let's explore some pictures. So here's a toddler. This child's about 2 years old and he's doing a simple puzzle, but he's also classifying those objects, those round cylinders by color, but also by size. These two girls are 4 years old in this picture, and they have taken a balancing game and started to classify and sort the chairs for this balancing game by color. So the animals in your block area, mine happened to be in a basket, and this little girl has started to classify the animals by putting them in groupings of where they live, and as well as what kind of creatures they are. So all the giraffes are together, all of the elephants are together, and then you can see she's started to add in some other ocean animals. This little boy was working on patterns. We had these castle blocks on the table, and then as a loose part in our classroom, we have flat gems, and you can see his pattern of pink, green, and a teacher came over to facilitate as he was placing these gems, and she recognized, oh, you have a pattern. So she started to repeat pink, green, pink, green. And at the very end, you can see that there's two pinks, and he goes, wait, I need to find another green one. So he added then another green one into the mix. So this might not look like classification or patterning, but when you look at it, this child is building with solo cups, another loose part that we use in our classroom, but you can see how he's inverted them to create a very tall tower. We might revisit this picture a little bit later when it comes to measurement, and I'll talk a little bit more about that. This was an activity or a learning opportunity that we had in our garden. We were going to plant a surprise garden, and this little girl did not want the seeds to be mixed. So she went and found some cups that she was able to sort this box of seeds. So you can see that she's classifying these seeds by shape and color. This is another little one. These are some beads that we had donated, and I think these might actually be coasters. So we might put this out and children can create their own patterns. And we have classified when we first set up this activity by color. Here's the activity that we've created, and it's just a laminated piece of paper with some circles and a basket of flat gems or marbles that are from probably the dollar store. We do laminate a lot of our papers. An easy tray that we use sometimes is just a cookie sheet from the dollar store, creates a kind of a stable place. So this one says match the colors and finish the pattern. So as you can see, you can place the gems, and then the last space is left blank. There's those erasers again that I talked about earlier from the dollar bins at Target. And then this is just a simple little muffin tray, and leaving it open to how the children might want to sort or classify. So maybe they're going to put all of the same objects in each of the containers, as like that top row shows. They only have one cat in each tin, and then, or they might start to classify them and putting them all together. So all the little pink birds, all the little red birds. But really it's open-ended, having the children explore. And then as teachers, we can ask questions and facilitate what we are observing the children doing. This one I created when I had a class that was very into treasure and sparkling things, but I was realizing that we weren't exploring patterns as much as I was expecting for our age group. So I created these tongue depressor patterns using little glittery gems, as you can see. And then what I've done is I've marked one set with a dot. So that way for me, it's easy to pull out and make sure I have all of them. And I might use these, they might just be on a shelf for the children to engage, or I've used them as a transition out of group time before, where I would have all of them that have the dot, and then each child gets a stick with the pattern. And I would say, okay, I have a pattern that goes blue, clear, blue, clear, blue, clear. Who has my matching pattern? And then the children can recognize, oh, that's the same pattern that I have. And then we can make a match. This one was created for a younger group of children. These are like Lysol wipes, like disinfecting wipes, which we probably go through quite a bit of now these days, if not before. And then I have corks, and I've cut a hole on the bottom and flipped over the container. So that way it's easy to empty as a teacher if we're wanting to reset. And unfortunately, you can't really see it on the other picture, but the other one has a slice where they can drop in these chips, probably found from a thrift store. But I liked the color combination of yellow, red, and green. And then I had also extended this activity, and some of the corks have the corresponding colors marked on the end of them. So another way to utilize these resources in a different way. And then here's another one, classification by size. These little nests you can find at your hobby or craft store, and then corresponding egg sizes. And this one, children are classifying by where modes of transportation and where they might go. So this little tackle box or embroidery box, I'm sure I got at a thrift store or maybe hand-me-down or donated. And so at the top, we have pieces of paper that look like the sky. The middle row is a map of roads, and then the last one is water. So children can classify where these modes of transportation might live. So also, again, reinforcing one-to-one correspondence, one object in each of those little boxes. Here's another one to help with patterning. So I've just taken some squares of colored paper and created patterns. I might put them out with a little box of animals or something that corresponds in color, or these little plastic chains I think I got at the dollar store at one point in time. But other resources like Discount School Supply or Lakeshore might also carry linking chains, which are a great way for patterning and measurement. So this one, you can put them out on top of, and then you can create a chain by connecting them. You can see how long can your chain become. It opens it up for a little bit more exploration. This is an egg carton that we had donated, and I just painted the inside, creating a pattern, but also classification by color. And we have another container of flat marbles. This one I've added a soup spoon, which is kind of a different motion in order to pick those gems up, just to reinforce fine motor development. And then this one is a Venn diagram, which we can introduce to young children. So we have white, black, and in the middle we have things that are both black and white. And I've just created a collection of objects that fit within that category. So we have things like bottle caps or little pieces of a pencil, a die. You can see there's like ribbons that I found that have black and white. So white objects will go in this side, black objects will go in this side, and things that fit into both categories go into the middle. Our next strand is measurement. So children begin to compare objects, expanding their understanding of comparing, order, and measuring objects. So this is an area that is not within the infant and toddler foundation, California Learning Foundations, but it is something that they've developed during their preschool years. So the substrands and foundations for measurement include comparing by length, weight, and capacity, using language, bigger, longer, heavier, taller, placing objects side by side to make comparisons. That's an example of the child that was standing by those red Solo cups. Their body is often a standard form of measurement. And then using non-traditional tools to measure. So here's another little one. Look, my tower is as tall as I am, right? So he's standing next to it. It happens to be sitting on a table, but we could add another element or tool of a measuring tape, which you'll see a little bit later. Again, what is my body? Because that's what's important to the child in comparison to this body puzzle. So in my classroom, I have tools that are available for the children to use. These are tape measures that were from a learning catalog, probably Discount or Lakeshore, that are pretty durable, as you can see. And as they explore how to use them, this is an appropriate way. And then it's my job as a teacher to help facilitate, oh, it looks like you've wrapped this around the chair. What part of the chair might you want to measure? And then demonstrating how they can use that as a tool of measurement. So here's one. This was pre-COVID. I will tell you that. But here we are, one very great example of spatial relationships. But we have all of these children that are here experimenting with creating flubber or slime. So I'm pretty sure that there is 14 children that ended up at this very small table, but we were able to divide and measure the cups of supplies that we were needing in order to let everyone have a turn as we created this mixture. Here's a form of measurement that was part of a experiment that we had done. We had someone bring in hornworm caterpillars. You can find them on tomato plants, and they're a pest, so people are usually willing to give them to us, but they grow quite quickly. So this is the same caterpillar or worm, and you can see it was less than an inch, and then over time it becomes quite large. They're pretty fascinating. Again, using tools like rulers to measure. So this was some wheat that we were growing, and we continued to measure it as it grew. I had a group of children one year, and they were very fascinated with the Titanic. And I tried to think, okay, so how can I connect their interest of the Titanic into something that would help develop math, right? So we learned from a book that we read that the Titanic was 883 feet long. And well, how long is that? So we decided to measure that across our college campus. And so we started at one end of our courtyard, and we measured at 100 feet intervals. So we knew that we needed to measure the 100-foot rope 8 times, and then a little bit more. We used a smaller measuring tape for the last 83 feet, but these boys did. And then they were able to see how vast that ship actually was. So using a 100-foot rope, and then they drew with chalk all the way across campus. It was pretty fascinating. Having a growth chart in your classroom gives children the opportunity to see how they grow over time, and that these numbers represent height. So we have a traditional measuring tape or growth chart that someone had given us, but you could also just use a cloth tape measure from your the sewing department or your hobby store. You can actually find them at the dollar store quite often. And then I mark with tape along the side, so that way we can go back in past times and see, oh, look, this is where you were when you first started in our classroom, and this is where you are now. So a sense of time is also measurement. Here's a non-standard form of measurement using paper clips. As well, you can also incorporate patterns. You could classify by size. Maybe you have 2 different sizes of paper clips. These are ribbon measurements that we have in our classroom. So this long teal one is actually my height. And when we measure the children, we'll often add a ribbon that's the same length. So that way, when they're wanting to measure maybe how long something is, they can also use their ribbon to measure, and then they hang next to our height measurement in our classroom. This was a simple activity. All this is some laminated paper that I've cut into strips, and then we have shorter on one side and longer on the other. Young children might need help understanding what shorter and longer means, but it also gives you those terms. So they were all originally the same length, and I just cut them in different intervals, so that way you can place them and classify them, whether they're a shorter piece or a longer piece. Here's some of those standard forms of measurement and tools that we use within our classroom. We have measuring cups, which are usually for cooking, but having a variety of different measuring cups. And then you can start to have conversations around maybe your sensory table with, oh, I need 4 1/4 cups to equal the big 1 cup green cup, or tablespoons, or half tablespoons, or teaspoons. Also, here is some other demonstrations of different types of traditional measurements. In my classroom, I also have a jar full of 1-foot dowels. So the children start to learn that 1 foot is 12 inches, and then they can also use those to measure things. The next area is spatial relationships or geometry. So as infants and toddlers, it is spatial relationships that they're exploring and developing. They're developing that understanding of how things move and fit in space. This often revolves around how their bodies move throughout space. And then once they come into the preschool foundations, it changes to geometry, which also includes the property of objects, shape, size, and position, and the relationships of objects in space. Substrands and foundations include identify, describe, and construct a variety of shapes. Create new shapes, pictures, designs, and combinations of shapes. Understand positions in space. So and underneath that you have in, on, under, up, down, inside, outside, beside, between, behind, in front of. So when having conversations with children, you can often incorporate those rather than just saying, oh, they're over there. Or you could say, oh, they are next to, or they are between the two shelves. So just adding some of that math language into your activities and dialogue with children. So here's a little, a toddler, and she's building with some large foam blocks, but not only her relationship to this structure, but how this structure is being created. So this is outside in our yard, and that spatial relationship of, can my body fit or reach that next stump? Spatial relationships, including shapes. I have a large building book, and this child was wanting to recreate one of the pictures that he saw in the building, and a teacher was there. One of our college students was there to help facilitate and ask questions and make observations. Puzzles are an excellent way to explore geometry and those shapes and how things fit together. On our light table, we'll often use these little tiles. This is actually from a really fun board game, if you like board games, called Blockus. And it's these little clear tiles and the way that they fit together. In the game, you're trying to fill the board against an opponent. In our classroom, we just have them out for children to explore how things fit together. So the concept of design and creating new shapes. This is just some rocks, and there was some chalk drawings on the ground of some different lines that was created by someone else, and this child has placed rocks along those lines and those paths. Spatial relationships. So boxes are an excellent way to explore your body in space. These children were very, very young, threes, when we were exploring this, and one body could fit. And then they said, well, I want to get in. And so they all joined in, and they had the conversation of, I don't think there's enough room for this next little girl to get into the box with them. But look at that, they problem solved, they figured it out. If I've moved my body on this side, or if I lift my body up in space, there's room for my friend. Again, she's created a perimeter or a shape, but also classification. She's put all of the purple things inside of this, this shape. Another spatial relationship one, these are blocks. This child is creating a path that shows the representation of like dominoes. I don't know if you ever did that as a child, where you stack up the dominoes and then you tip them over, cause an effect. He used all of our unit blocks that were the same size to create this very long pathway, a lot of impulse control from his peers needing to happen in order for him to finish the path. But how far do I set this block in order for it to reach the next one? Another one with shapes. This is again on our light table, and we're exploring just some simple shapes using gems. I've used like a page protector to create plastic to create an outline of a shape for them. Circle shapes and that pathway of some tires out on a yard. Another exploration of cylinders and circle shapes. These are napkin ring holders and some little people-shaped dowels. Also like correspondence of one-to-one correspondence. Also measurement, that some of them need one napkin ring holder, and then some of them need to be stacked in order for the shape, the person shape to be completely concealed inside. And then this is nature mandalas. This is one of my favorite activities to do. And this is just a collection of objects that, and then children can create a pattern or a design using those things. And the frame that we're using is actually an embroidery hoop that I've gotten at the thrift store with a piece of fabric in between. This one was created by a child, and you can see how they've, the elements of design that they're using within their designs. Symmetry comes up a lot with nature mandalas. Face puzzles. So I take a picture of the children and I put a white border around it, and then I color it in, so that way for some of our young children it becomes a little bit easier. And then you can see as they continue to explore these, they might put different people's faces together to create some kind of silly pictures. These are curlers, but good for classification as well as shape and seriation of sizes. Creating new patterns and pathways using some bottle caps that I just kind of drew some different lines on them, and then seeing how the children use them. They could create a square, they could create a different pathway, depending on how they line up the ends of the lines. This is an activity we call cubes and tubes. So I've taken some 1-inch PVC pipe and cut it into different lengths, and then I have 1-inch cube blocks. So depending on the length of the tube, that also represents and corresponds with the amount of cubes that can fit inside the tubes. This is a collection of different clear vessels that we have. This was created for a younger infant or toddler classroom. And then we have some yarn pom-poms that we've created. And then seeing how many fit into these different clear containers. What do they look like? You as a teacher or care provider, you can have conversations of like, ooh, 7 pom-poms fit inside of that big jar. This is a game that we play usually as a transition activity. So I have a die here made out of paper, and it has different directional language and spatial relationship language on it, like under and in. And then you roll the die, or a child rolls the die, and then places the little toy or whatever next to or inside of. So this one says under the cup. So how do you put something under a cup? Well, you can create it where you turn the cup over for it to be underneath it. This one is simple mustaches. I had a teacher who was really excited about mustaches, and they liked mustaches, so we created a game about them. So these are I just traced mustaches from like party supplies area or store, and I made them a little bit bigger using some different colored felt, and then children can look at the silhouette and try to match the mustache. Keys, there's one where I've just copied the keys, and then they have a bowl of keys that they have to look at the shape to make those representations, or just outlining them and then having them match. This one, these little foam cubes I found at the dollar store, or maybe in the dollar bins at Target, and then I created some different patterns. On the patterns, I have given the number of cubes that might be needed to recreate this shape. Mathematical reasoning is the final strand of mathematical development that is recognized in the early learning foundations. So using the use of mathematical thinking to solve problems that arise in everyday environments. So the substrands include identifying a problem, applying a solution, making a prediction, and then having equal parts. So those are all areas of mathematical reasoning that children are developing in the preschool years. So this could be, oh, how many napkins do we need for snack time? We identified a problem. How are we going to apply our solution? Maybe we'll count our friends. Maybe we'll count the water bottles of who's here today. Some of the activities that we have to explore this further. So this is an area that I might set up that has these two gloves that have weighted pellets in them. They're just from the dollar store and I stitched them closed. So ways of creating 6. So I can use the dominoes to create two on one hand and 4 on the other. Then I can have them find that number in the represented in a numeral. This is usually just an option at like free choice time, and they can explore it however they choose. Cubes and tubes again, kind of problem solving. Making that prediction of how many cubes will fit within the tube. Here's egg crates again with a basket of buttons. Some young children might just be classifying and sorting with the colors that are painted in the egg crate, or they might be rolling the die to create the mathematical problem. So I've painted a plus sign and an equal sign, so they can put two purple buttons in this one, 3 purple buttons in this one, and then they can move them over to that last spot to create that mathematical operation. Estimation jars. So this one I've just created a little piece of paper that sits on the shelf next to these jars that have collections of different things, and they have to estimate how many objects are in each jar. And then they can either write it or draw the number of objects in the jar. And then after they've made their estimation, then they can empty the jar to see how many were in each jar. This little wind-up toys, I don't know if you guys remember these. This little gorilla, he jumps. And so you can wind him up and estimate how many times he's going to flip. This is a good way to have children make predictions and see if their predictions are correct. So this is where we normally would do a table walk, but unfortunately, since we can't be in person together, we have shared those photos with you.
This is Maddie jumping back in, talking about the Effective Math Center. So here's some activities, but what was this looking like in your classroom? And an Effective Math Center is in a clearly designated space in the quiet area of the room. You're going to have your larger spaces and your more active areas like your dramatic play and your blocks. And if you're having a specific math center, clearly designated space in a quieter area of the room. You want to include a large work area, so that way children can pull out activities, and if you have them on shelves, there's an area available for them to work. I mean, ideally, we're talking a large work area, but we do know we get what we get with our classrooms sometimes. We want to have organized shelves with aesthetically pleasing containers. So that's why, as Lorenda was talking, you saw some gorgeous pictures and things like trays and baskets and cookie sheets to give that container available for children to work with their projects. providing a rich variety of developmental math manipulatives relating to the different math strands, the ones that we just talked about. So if you're looking at your math center and realizing that you have a lot of patterning and a lot of things having to do with numbers and number sense, but you might be missing classification or some of the other substrands, just having an awareness of that. Providing a place to display completed and in-progress work. Again, this is our goals, to be able to have that space within our classroom, but if we can, that's going to help to boost children's math development. And then containing books that support mathematics, because as much as we are promoting mathematics in this, we do recognize that math is not a standalone domain of development. It's integrated with literacy and with science and all of these other areas that children are growing and developing. And even though Math Center, that's what we're looking at on this slide, acknowledging that math doesn't just take place in the Math Center. You saw math in blocks, you saw math at snack time, you saw math throughout the classroom. And so while you might have a Math Center to have that central area for math development, having space throughout the classroom that is dedicated to math growth and development. Bringing some context to our math materials, they're going to allow for active manipulation. You saw all of these. They weren't pictures or posters up on a wall. These were activities that had active manipulation. Have a clearly defined mathematical purpose. You saw that they were sorted into categories depending on their substrands. Open-ended or self-correcting. So having ways that children can see, okay, is this 6? Is this the way that you might use this? Or, open-ended, many different ways. A self-correcting material might be cubes and tubes. There are only 3 1-inch cubes that are going to fit into the 3-inch pipe. Based on children's mathematical skills, knowledge, and interests. So you're noticing, what are children interested in? How can we incorporate math into that? And rotated to meet children's changing developmental needs and interests. When Lorinda was talking about having her young 3s in her classrooms, and she brought out boxes, and that's how the children were figuring out how many children fit in there. But then maybe you notice that the children are a little bit older and they're interested in different things, or you have teachers who are interested in mustaches, and then that the children become interested in mustaches because of that, and the enthusiasm grows, and so you rotate out materials that are based on children's changing needs and interests. And so some of the materials, this is a list of some of the things that we looked at today that I just wanted to put out on the page, so that way you could look at it and see these are all materials that you could use to create math creations within your classroom. Straws, the fancy glass beads. I know Michael's and other hobby stores and craft stores will have sales and clearance areas, and that's where great place to get glass beads. The cookie sheets or baking trays from dollar store. They are not the best item for actually baking on, but they are fantastic for providing a space and a work area for math learning. Novelty erasers. I find these in the Target dollar spot or at the dollar store. Seashells. Depending on where you're at, you might be able to go to a beach and get these for free. Otherwise, finding different places to get them and paint on them. Flat rocks, you saw some activities with that. Bath toys, again, that's a Target dollar spot or dollar store for me is where I'm finding those. Pool noodles can be used in so many different ways, including what we saw here, but cut up, used as ramps, used cut into circles to make counters. Playing cards, which is a material that I wouldn't have necessarily thought of as a math material that you could use. The pom-poms, measuring cups, because how many of us have half-done sets of measuring cups in our cupboard that we should probably just get rid of because they don't all match? Talking to parents about, do you have any from a set that don't match? cubes and tubes. We're using those 1-inch cubes and PVC pipe, or another way of making the tubes. You saw bottle caps of plastic water bottles. If it's a recycled material, you can reuse it and create something completely different by just drawing lines on them, and then children can create shapes. Solo cups, you saw the tower. Also, they have small 2-ounce solo cups, which I will fully admit has gotten some funny looks when parents walk into a classroom. But as a math material, as a manipulative, they are fantastic and so developmentally appropriate, and are something that I've seen children really engage with and enjoy. Flat marbles, muffin trays. Again, you can find these at the dollar store. Not the greatest for making muffins, but fantastic for classifying and sorting, for putting a piece of paper at the bottom and then being able to say, to give that opportunity for sorting. Plastic gems, Clorox wipe containers that if they are cleaned out, I feel like we're going through a lot of those right now. And so those might be available to you. Egg cartons to paint the bottom of them. Cloth measuring tape, Lorinda mentioned, those are another item that can be found at the dollar store sometimes. Paperclip chains, height ribbons, hair curlers, bunch of different kinds of jars. You will notice that the estimation jars were glass, which some programs and some teachers are comfortable with. Some would prefer a different type of container for using jars. Peanut butter jars can be cleaned out as long as there's no nut allergies in your center. But that's something you'll have to think about just with personal comfort. Stumps of logs or tree cuttings and branches that you can cut and make rounds. Game pieces, you noticed Blockus, but there's other games too that if you are missing a piece or you find them at a thrift store and not all the pieces are there, make great math manipulatives. Boxes. How many people are getting maybe Amazon boxes, or you're able to find refrigerator boxes? All sorts of different kind of sizes of boxes that you can use. Tires, when I've had tires in centers, we drilled holes in the sides to make sure that there was adequate water drainage, and then also spray painted the inside of them white, so that way it helped if there were any critters, we were able to see them. Specifically at my center, it was wasps that we were keeping an eye on, and spray painting the inside of them white helped us to make sure that there weren't any wasp nests that were growing in those. So again, just tips and tricks, things we keep in mind with math materials. And then embroidery hoops. So those are those wooden hoops, and you get two. You can put a piece of cloth inside of them, and those were what Lorinda was using to make those math mandalas. And then laminated papers, so that way they'll last and be reusable for patterning, where you put a variety of patterns on there. You could use stickers even to create those patterns. Phone numbers with the play phone, that Venn diagram. You could use laminated papers for matching, and also photos of the children. You laminate those and cut them up, and then can be used as a matching and a puzzle activity. So just wanted to make sure that we had all of those materials listed for you, so that way you could see them and be able to go out and find some of them for your classroom. And then when you are working with children with all of these materials, some of the ways that you can facilitate children's learning: engage them in formal pre-planned math talks or math workshops. Maybe that's where you sit down and you say, Evan was wondering how big a blue whale is. And then we have that planned math talk where we use all of this rich math language with measurement and feet. And how are we going to do this? Engaging children in informal math talk, where we use their play and we join them in guided play. Modeling mathematical language. Asking children questions to assist in their reasoning. Why did that happen? Why did you think that this went next? How did you figure that out? Suggesting ideas for materials, noticing, and maybe that's verbally suggesting, maybe it's just kind of moving that one block closer that they might need. Asking children to communicate their thinking. Why did you do this? Tell me about it. Connecting children's informal math knowledge and formal mathematics. How did you know that this was a square? And they might know because they matched it, or maybe they noticed that the sides were the same. So using length of the sides, using the word vertices to talk about the corners. Children will gain so much informal math knowledge through play, and we take it to the next level by using the language to turn it really into formal mathematics and giving them that basis of knowledge to take it to the next level. Encouraging children to problem solve. Assessing and documenting individual children's learning, which is going to help you to then figure out what do the children in my program need to be able to take their math learning to the next level, and meeting the needs of all learners in your classroom.
I just wanted to thank you all for attending, and if you have any questions, please feel free to contact me via email. It's there on your screen. We will also be holding a question and answer session after this recording. Thank you.